Today's class we will discuss about finite languages versus infinite languages. So we all know that what is a finite representation of data and all. So what is finite language and what is infinite language, and we will see some of the examples related to the finite language. If suppose any of the language, if they mention any of the language, how to represent that language as a finite language or infinite language, that we will see. So you can see the definition of the finite language: the language which contains a finite number of strings. So you can take the finite number of strings. You are having two main important things: the language which contains the finite number of strings, this is the first one. Second, the length of the every string is finite. So which of the language is going to be satisfying these two conditions, that you can call it as a finite language. So means you need to decide that you can able to count the number of strings, as well as you can able to say the length of the string also to be finite. So we'll see the definition of infinite language also, and we will go for the example. You can see the infinite language. So the language which contains infinite number of strings and the length of every string is finite. Length of every string is finite, that you will call it as a infinite language. So you can compare the definition: finite language and infinite language. The length of every string, it is common to the finite language as well as infinite language. The length of the particular string is common for the finite language as well as the infinite language. But when coming to the language which contains the number of strings will change. The number of strings in finite language can be countable. The number of strings in the infinite language is an infinite number of strings. That is only the difference between finite language and infinite language. So whenever we are going to be finding the elements, we need to identify that whether the particular string is finite string or means a particular language is a finite language or infinite language. You can see the example. In this example we can find whether the given example or the given language is a finite language or else infinite language. So you consider the string here. You are taking all symbols, means alphabets. You are having sigma equals to a comma b. Sigma equals to a comma b. The set of input stringers, it is a comma b. So from the string, so we are having the language L equals to a to the power n, b to the power n, and n greater than or equals to 1, means a to the power n and b to the power n. So from this string we are going to be generating a language. So a to the power n, b to the power n, n greater than or equals to 1. So whenever you are going to be representing the language, you can see we are writing the two languages here. First language L, the possible length of the given string L. So you can see the first one, null AB, means I am taking first null representation. Some you are going to be representing it as null, and some people they will represent it as a lambda. So you can take either null, so is a null, so is a sigma star indications, means the possible set of all elements. Sigma star equals to, this is the sigma star indication, sigma star equals to null, and you are taking the elements n equals to 1, n equals to 2, when I am taking n equals to 1, so the first one is empty set. Second you are going to be taking n equals to 1, a to the power 1, b to the power 1, and next you are taking n equals to 2. When I am taking n equals to 2, a square b square, means a b b, and I am taking n equals to 3, n equals to 4, like that. So whenever you are going to be applying the n value, so it will change. It depends upon the n value. Means the language, the possibility of the language, you can able to increase whenever n value is changing. Means you cannot say exactly the number of elements or the number of strings ought to be defined. So this kind of language means, because you cannot say, you can call it as an infinite language. You cannot call it as a infinite language. When coming to the second language, L1, from the language L, you defined the another language. Means it's nothing but L1, it is subset or equals, it is subset to L1, it is subset to L. So L1, it is subset to L. So this number of strings, so you can countable here AA, BB. So this is AA, BB and AAA, BBB. Means the elements, whatever the number of strings existed in L1, that is from the infinite language L. So the subset of the elements from the existing things, so that you are going to be defining as a separate language, that you will call it as a finite language, So that is the difference between the finite language and the infinite language. So if you are having any doubts, you just comment in the comment section. Thank you.